This conference will now be recorded.
All right. So we have already discussed about if-else later, right? If-else, if-else, if-else later. If you look at the same example, we have one example, right? So where we have taken a number and mapped that number to a day, right? So let me open that. Conditional statements, right? So if you look at this example, so this example is mapped the number to a particular day. So 0 maps to Sunday, 1 maps to Monday. Likewise, I have the mappings, okay? And the user can enter any of the number in between 0 to 6. So based on the number that user enters, so I am going to say the respective day, which is mapped to that particular number, right? So it's printing. If you look at, so here I have multiple if-else statements, multiple if-else statements. So if you look at this, in this case, so it's going to check this one. If this doesn't satisfy, if this doesn't evaluate to true, then what will happen? It comes to else. And in the else, again I have if condition. If this doesn't satisfy, then it comes to else, and again it's going to evaluate this one. So meaning that if user enters a number 6, then what will happen? So this has to evaluate, this condition has to evaluate, this condition has to evaluate, this has to evaluate. So it's going this is evaluate all these conditions are not. And of course, as the number is 6, this evaluates to false. All the things, all the conditions returns false. So it doesn't get inside any of these if statements. And finally, it comes to day number 6. On day number 6, then it will come here and it will print. However, it still has to evaluate all these expressions or not. It has to evaluate all these expressions, which is unnecessary, right? Just imagine that. So you have a room inside, you have a room and you have a switchboard. You have a switchboard in your room, right? Or in your house. So you have a switchboard. So all these are switches, right? Now, so I have asked you to switch on a particular fan or a light, and you don't know which switch is mapped to that particular fan or a light, right? So you don't know which is mapped to this particular light. So which is mapped to this particular light, you don't know. Okay, so what do? You don't know which is connected to this. So what you do, you will start from the beginning. You will switch on this. No, it doesn't work. Then you will switch on this. It doesn't work. You will switch on this. It doesn't work. You will switch on this. Yes, it will work because it's mapped, right? So this is all about, like, so you don't know which switch is mapped to this. Okay, you don't know which switch is mapped to this, so you have to evaluate by going one by one. First switch, second switch, third switch, like that. But if you already know that, so the other case, like if you see, you know that, okay, so this is mapped to you. Suppose you have written something over this. Okay, so this is the light and this is the fan. Okay, this is for fan and this is for maybe something else, bed light. So you have written something like, okay, and each switch is mapped to something. Then automatically you will be able to directly go to the particular switch and you will switch on, right? So you don't have to evaluate this. Directly you will jump into this and you can switch on, right? So what is the difference? Effort is going to reduce or not? The effort reduces definitely. You are jumping directly into this particular switch and you are switching on. In the other case, you are checking the first one. Checking the second one, third one by one you are verifying, correct? That takes definitely time, whatever time it is, maybe a minute or a half minute, whatever it is, but it's extra time. So that's what in programming, when you have more number of if else statements, it is not recommendable to use. It is not recommendable to use. Just go with basic if else ladder. If it is four if conditions, or five if five, max five, 4 to 5. If there are 4 to 5 conditions, then okay, you can go with the basic if else statements. But if you have more than that, if you have more than 5 conditions, then it's not recommendable to move with this basic if else statements, if else later statements. So the recommendable is, so you have to, it's recommendable to go with another solution. What is that? Is a switch statement. So we have something called switch statements. But when you have multiple things like this, you have multiple conditions to check. Then recommendable is what? Go with the switch statement. With the switch statement. So how the switch statement works? How it works? Okay, let's understand that. Let me save this file. Okay, now switch statements. So it's going to be like, during the compilation time, the compiler prepares something called jump table. Okay, compiler, during the compilation time, compiler is going to create a jump table. Okay, jump table. So jump table describes, or jump table specifies, okay, so which number, which input, or which case should be mapped with, to what condition. Okay, the mapping will be tracked as part of this jump table. We call it as jump table. Okay, we call it as jump table. What will happen? It's a kind of mapping. It's a kind of mapping. So if the input is so a, then you just move to the condition, or a particular case directly at the execution time. It directly executes that particular thing instead of evaluating case by case. And this jump table preparation and all happens during the compilation time by the compiler. Okay, so we have two phases, compilation and execution. So during the compilation itself, so compiler prepares the jump table. What is this jump table? This is going to map, okay, each it's going to map each input to a particular case. Okay, so if you look at how the syntax will be, the syntax will be simple. Okay, the syntax will be simple and straightforward. So we have something called switch. This is a reserved keyword, switch keyword. Okay, switch keyword. So here you can pass your input. Okay, just input. Okay, so in our case the input is what? So the numbers 0 1 2 3 4 5. Okay, so let me take that number as something day number. Okay, day number. So you can read this from the keyboard, but still we did not discuss about how to read the data from keyboard. I'm just giving some random things. Okay, right. So whatever it is, if the day number, so I'm going to take that input number. This is what my input. Okay, input value. So this day number, now I'm going to write, I'm going to define the cases. I'm going to define the cases. Okay, so here my cases will be like, should be equivalent to the input. Meaning that whatever the input you are giving, so your case should be with that. Your case should be with that input. Okay, meaning that what are the possible inputs I have? 0 to 6. So you need to define the cases. You need to define the cases from 0 to 6. So case 0. Okay, case 0. Here you can define it. Okay, you can define your logic. When input is 0, what is my logic? So my logic is simple, right? My logic is, if the day number is 0, I have to print this particular thing. It is Sunday, I have to print that. That's it, right? So Likewise, so how many cases I have to write, how many input values I have, depends on that. I have to define my cases. I have total 0 to 6 input values, so I have to prepare those many cases or not. I have to prepare those many cases. Okay, likewise I'm going to prepare, so case 0, case 1, case 2, case 3, case 4, 5, 5 and 6. Right. Okay. So I have 6 cases now. So it is mapped to Monday. It is mapped to Monday. It is mapped to Tuesday. Right. So I have defined my cases like this. Now let's understand that. So does it have any challenges, or it's fine, it will be fine, or what? Okay, now if you look at the jump table, what will happen? So during the compilation time, the compiler is going to keep the values here. Okay, so this maps the input value 0. Okay, the input value is 0. So that 0 is going to map to case 0. That is going to map to case 0. If the input value is 1, that will map to case 1. This mapping will happen during the compilation time, case 2. It's going to map to case 2. Like that, it will map all the cases. Okay, now input value I have entered 2. Then during the execution time, what will happen? So directly, as the number is 2, it directly jumps to this particular case. So it doesn't evaluate this, it doesn't evaluate this. Okay, so these are not going to evaluate. Instead, it directly jumps from here to here and executes this particular case statement. Right? Hope you followed and understand. Let's understand, like, by executing this, what are the challenges we have around this, or it is absolutely fine, or do we have any issues with this piece of code? Okay, let's understand. Right, so let me compile it. Java C switch. Do we have any compilation issues? No. Okay, no compilation issues. Now let me run this Java switch statement example. Okay. Okay, so see here, we have some problem here. What is that? It's a bug. It is what a bug. What is the bug? It is printing. It is Tuesday, Wednesday, Thursday, Friday, and Saturday. So it's giving all right. But what we are actually expecting, our expectation is to be what? It should print only it is Tuesday, but it is also printing Wednesday, Thursday, Friday, Saturday. So which is wrong. So I'm not expecting this. My expected output is only it should print it is Tuesday, but instead it is printing all the other things. What will happen? What is happening here? What is happening here? If you look at, so it is jumping into the case 2. That is fine because my input number is 2, so it comes here, it comes here, and it printing it is Tuesday. But it is not stopping over there. It is not breaking at this case. It's still falling down. From there where it matches the case, from there it just falling down and executing all the remaining cases. So case 2, case 3, case 4, case 5, and case 6. That's the reason we see Tuesday, Wednesday, Thursday, Friday, and Saturday. So that we have to stop it, right? That we have to stop it. So that is where, so we have a syntax to break it. Okay, I wanted to break this. So if it is a case 0 is matched, then you execute the logic and you break the switch statement. You come out of it. You come out of it. Okay, that's where we can use break. We have statement called break. So for every case we have to use break statement. This is important. Okay, otherwise it will execute all the remaining cases from where it matches the case. Instead of executing only that particular case, it will fall down till the end of the switch block. Okay, it falls down till the end of the switch state. So we have to use break. Okay, we have to use break. We have to use break. All right. Hope you are following. Okay. Now let me. This is fine. This is fine. Now let me recompile and re-execute it and see is there any issues that we found. It is Tuesday. That's what our expected output. Perfect. Okay. Let me give some other number 5. Okay. 5 is mapped to what? Friday. Okay. Let's see. Our expectation is what? Friday. So it's giving Friday. Yes. Perfect. Okay. Perfect. Now what I give is, okay, I'll give some different network issue. Can you hear me now? Hopefully.
Yeah. Yeah.
Okay. So yeah. So I was saying about this else block. So if none of these cases matched, then what will happen? So we have to say the user, boss, you entered something wrong. So please enter within the range. We need to handle this or not. So that is what we have a special syntax here. That's what a default. Okay, that's what a default. Meaning that if there is no case matched above, like for the input value, none of these cases matched, then what will happen? So by default it comes here and it is going to print this. Okay, it's going to print this. Okay, so now see that the same thing what I can do is, okay, there is error. Okay, compiling, yes. Now let me execute it. Java switch. Okay, so it's saying that no day found for the given number. Please enter the number in the range of 0 to 6. So it's working properly or not. So that is how we can handle when you have multiple if else conditions. Okay, let's say more than 4 or 5. Then it's recommendable to go with what? Switch statement. How does switch statement works? This is going to work in this way. The syntax would be straightforward. So you'll be having switch is a keyword. So here you will have input value. You will have input value and followed by cases. Okay, you can write your cases here. Okay, case 1. Okay, your logic and what is the syntax here? You have to use break for every case to come out of it after executing that particular case. So like this you can write the logics and you can write the break. You can use break statement and you can write how many cases you have. You can write n number of cases, no limit. Okay, again you can write any number of cases here. And at last the recommendable thing is what? Default. The recommendable thing is what? Default. And you write the default logic. That's all. for this, do we need break for this default? Not required, right? Because this is at the end of the switch statement. There is nothing more to there is nothing more to execute. So break statement is not required for default. Okay, just a default is enough. That's it. Okay, so any confusions around this? Let me know. Are you good? Switch statement. Are you fine with this? Are any questions around this? Aditya? Good. Okay, Shankar, good. So this basic fundamentals again, definitely must be come across these basic things apart from along with other in other programming languages as well. But just a kind of revise our assumes and follow. Okay, switch statement. So this instead of if else later, when you have more than 5 if else blocks, then go with what switch statement. Otherwise, just you can use simple if else, whatever you feel comfortable. But switch is better. Switch gives better performance. Okay, right. So then let's move on to iterative statements. Okay, iterative statements. Iterative statements. Okay, iterative statements. All right, so what are the different iterative statements we have? We have while and do while, and we have for loop and for each loop. Enhanced, we call it as enhanced for loop. Okay, for each loop. Okay, so all these are like, yeah, we can call it as loops. The iterative statements are looping statements. Okay, so whatever we have seen so far, those are conditional statements. If the condition is true, then it's going to execute. Otherwise, that block of code will be skipped, will not be executed, and that is only once. And these statements, these flow control statements, okay. So it's about that. Okay, but I'm going to execute the block of code for n number of times. If the condition is true, yes, I will execute the same block of code a number of times, and that n you have to define that n, meaning that how many times you have to iterate through. You tell me, I will execute those many times, your logic. Okay, I will do that logic. Okay, so I wanted to print 10 times. I wanted to print hello 10 times. Okay, say for example, this is system.out.println, the short form I'm using SOP. SOP is what? System out println, just for our understanding. Okay, like this I wanted to print, okay, how many times? 10 times. So my actual logic is what? Printing hello is my actual logic. Printing hello is my actual logic, and the same logic is repeating, right? The same logic is repeating. How many times? 10 times. Okay, there are 10 times, I can write it 10 times, no problem. So what if the statement to be executed, the same thing to be written 100 times? What will happen? The same thing to be written for 1000 times, 1 lakh times, or 10 lakhs times. So that is where actually you will see the impact of this iteration process. Okay, when you have a requirement to execute the same thing again and again, then definitely we need, okay, some sort of this kind of iterative statements. So for example, you have a list of a group of employees. Okay, list or group of employees. Now what is my logic here is I wanted to filter out the employees. I wanted to filter out the employees whose salary is okay, whose salary is greater than 100K dollars. Okay, so 100K dollars. So I wanted to filter out the employees whose salary is greater than 100K dollars. Then what you have to do? So I have to take the first employee and I need to check this condition. I have to take the second employee, I had to do this check. Third employee, I had to do check. How many employees I have? I might be having 1000 employees. For all the 1000 employees, I need to verify or not. For all the 1000 employees, I have to apply the logic. What logic I have to do is simple logic. This is what my logic, and this logic should have employees, right? This should be executed against all the employees, correct? So that is what the story here. Okay, list of employees. We are going to do the same logic for 1,000 employees by iterating this logic. That's where we are going to control using iterative statements. Okay, boss, you have 1,000 employees. Okay, so the condition is 1,000. Okay, so it's a kind of iteration. So I wanted to take some iteration counter. Okay, you can just imagine that some counter. So I'm just starting with my first employee. Okay, my first employee. So now then I need to check whether my first, the number counter number one is equivalent to 1,000 or less than 1,000, meaning that so my boundary, I know the boundary, right? What is the boundary or max count or max number of employees? How many I have? 1,000. Okay, that will be my max count. Now I'm going to write the logic. So this is what my logic: salary greater than, okay, or equal to $100K. Okay, $100K. So if this is what my condition, this is going to be my condition. If salary is greater than, okay, 100K, then I will print out do something. Okay, so employee details, I'll print those employee details. So here I'll print all the employee details, employee name, salary, etc., etc. All the logic goes here. Okay, but this is what my logic, and this has to be done how many times? For each and every employee. Okay, so I have to start with my employee first. Okay, employee number. Okay, so now I am going to check. I'm going to execute this. How many times? If it is not more than, if it is not, my number is, my iteration number is not more than, okay, not more than my max number of employees. My max number of employees is what? 1,000. Okay, that is what. So till my counter value is, okay, is less than or equal to my max count, you have to do this logic for me. That's what. So conditional, I'm going to do it. If it is if condition, if I write if condition, what will happen? If I write the if condition here, what will happen? What is the difference? So if condition executes only once, if condition executes this logic only once, right? If counter is what? 1, and the counter less than or equal to what? 1,000, yes, then it will get inside and apply the logic. So here we will increase my counter value because we have executed once and we are going to for the next round. Okay, but as it is if statement, it doesn't go back. The control doesn't go back, and it executes only once from top to here, top to bottom, and it comes out of it and proceed with the next line of. But that is not, that is not what I'm looking for, right? I wanted to execute this again and again. So from here to here again, it has to go back. It has to go back and evaluate the condition, and again execute this logic. Again you go back. Okay, again you go back and evaluate this condition. If the condition is okay, then again execute this logic, again go back. So it has a process. So it is keep doing it till what? Till my counter reaches what? My 1,000 employees. Then okay, 1,000, here it becomes counter value 1,000 plus 1, 1,000 plus 1. Then it comes to 1,001, less than or equal to 1,000. If condition fails, so then it will come out of the loop. That is what iteration. That is how the iteration works. That is how iteration works. So that is what. So here, if is not recommendable, so what we have to use? While. Not it's we have to use it. We have to use while or a for or any loops instead of just using conditional statements. Okay, so now what will happen? So if you interpret this, okay, so I have a counter value, say C, just a short form, and I have a max count. Okay, I'm just assuming as M. Okay, so the C is counter, max count is M. Okay, now C value is what? Initially what? Now max count is what 1,000, right? So 1,000. Now it checks the condition. What is the condition? Counter less than or equal to max count. 1 less than or equal to 1,000. 1 less than or equal to 1,000. So this statement is correct or not? I mean, it evaluates true or not? 1 is less than 1,000, of course. So it evaluates to true and get inside the loop and executes this. So here it is going to check this. It depends on that. This is going to verify, and what will happen? This is going to increase the count because it has to verify the second employee, right? Second employee. So one becomes what? Two. One becomes now counter value becomes what? Two. Because counter value I am increasing by one and play again reassigning my counter value. So counter value was one, but now it becomes what? Two. So again, it goes back to the condition counter less than or equal to max count, 2 less than or equal to 1000, 2 less than or equal to 1000. Correct or not? 2 less than, yes, 1000. So true. Again, it comes into the loop and it executes this. Again, counter is going to increase because I should check the third employee. I have verified first employee, second employee. I'm going to check the third employee. 3 less than or equal to what? 1000. So like this, okay, so like this, it keep executing the logic, okay, keep executing the same logic again and again, and at some point it reaches to 1000 plus 1, it becomes what? 1001 less than or equal to 1001 less than or equal to 1001 less than or equal to 1000, it is a false, right? 1001 is bigger value than 1000, so the condition is going to fail. The condition evaluates to false, then it will break the loop and comes out of it. So that is how you have to analyze these looping statements. Okay, so when you have the same thing to execute for multiple times, then you can prefer these iterative statements. So as part of that, just we have seen the while statement. Okay, so if you look at the syntax for while loop, you look at the syntax of while loop. So first you should have some counter initialization. Okay, counter initialization, right? Then condition, you have to write the condition. Okay, and this must be part of a reserved keyword. What is that? While. So here condition. Okay, so you will be having your actual logic. Okay, then counter to be incremented. Counter to be incremented by one. Incremented or decremented. So you can start from 1000 and you can come in reverse direction also. In that case, we are going to decrease the value. So either incremented or decremented. Okay, counter to be incremented or decremented by one, and then it goes back to while loop and it keep doing it. Okay, so this is what is simple logic, simple syntax. Okay, simple syntax. This is what simple syntax of while loop. Okay, hope you understand the importance of the loopings and in that the while loop. Okay, let's write a small program. Okay, let's write a small program. Let's write a small program. Okay, so I'll take the same thing, main method. Okay, okay, just in this while example. Okay, all right, so just let us print simple print statement for 10 times with simple example. Okay, for that I need a counter or not. So I have to take a counter variable. So let me start my counter variable with, and while is a keyword, and my counter value. So what is my boundary? Less than or equal to 10. I wanted to do it for 10 times. So directly I'm giving the value 10 here. Okay, my counter to be incremented or not? Counter equal to counter plus 1, and before that I'll write the logic. So what is the logic? Actual logic in my case, my logic is very simple. That's what, just printing hello. Printing hello. If you want, you can print the number also. Okay, counter, like what iteration, how what. So this is printing first time, this is printing second time, so just I wanted to print that also. Okay, hello 1, hello 2, hello 3, like that I wanted to print. Okay, so now if you look at this, right, a simple very simple while program. What it is doing, it is going to print this for 10 times. It's going to print this for 10 times. So you can analyze this by taking a pen and paper. Okay, you track this counter. Okay, one like you take something like this. Okay, counter. You take a counter, then you take the condition. Okay, you take the condition. Okay, condition, and you evaluate it. Okay, initially counter is 1 and condition is what, 1 less than or equal to 10. 1 less than or equal to 10, yes or no. This evaluates to true. Okay, this evaluates to true. Then it executes, it will print hello. Counter value is what, 1. Hello 1 it prints. Then counter is going to increase by 1, so 1 becomes now 1 2. So 2 less than or equal to 10. 2 less than or equal to 10. So just you verify 2 is less than 10 or not. Yes. So again it will get into the loop and it executes the statement hello 2. It will print again, counter is going to increment by 1. 2 becomes what, 3. So it goes like this. It keep doing that. Okay, 3 less than or equal to 10. It goes like this and it executes it. It will go through all the iterations till the condition fails. Okay, so 3 4 5 6 7 it goes up to what, 10 times. So the 10th time it's going to increment counter by what, 1. 10 plus 1 it becomes what, 11. Okay, it becomes 11. 11 less than or equal to 10. 11 less than or equal to 10, it will fail, right? 11 less than or equal to 10, it will fail, right? So that is where it will break the loop. That is where it will break the loop. So just analyze it and you can get through that. Right now, execute it. We have a C while example y2. Okay, let's compile, and I'm executing this. See here, it's printing hello 1, hello 2, hello 3, hello 4. Likewise, it's printing hello 10, but all are printing in the same line, right? In the same line because I just used print. So if I use print ln, okay, it will print that and keep the cursor in the new line. Okay, it will just keep the cursor in the new line and you can see it line by line. Hello 1 2 3 4 5 6 7 8 9. Okay, the line is that the simple statement is executed for 10 times. So that's what should be understandable. It should be understandable. Okay, then the next thing is do while. Okay, do while. Okay, do while step. Okay, so it is something like this. Okay, it is something like irrespective of the condition, you have irrespective of condition, you have something to execute first. But if you want to repeat that again and again, okay, if you want to repeat that again and again, then so you need to check the condition. Okay, for the first time. Okay, so it's a kind of something like this, a simple example, very basic example. So for example, so if you wanted to attend any sessions, okay, wanted to take any training session, okay, so the general people conduct a demo session, right? So to attend a demo, everybody can attend, no restrictions, no conditions, right? So for the first time, the first session is a demo session, so meaning that for the first session, no restrictions, directly you can attend. But if you wanted to attend from the day to the next session, you have to get the subscription, or you have to get the you have to pay the fee, or you have to get the card, or something what we call, you have to enroll it. If you enroll it for the course, then you are allowed to attend the remaining sessions, right? So that is what every day, like, so they are going to do a check out of like 1,000 members I have. Okay, so I will be checking like all the 1,000 members. I'll be giving a password kind of thing to join. Somehow I will manage it. Right? That's what every day it will be a default check from the second day itself. It will be a default check. If you have the valid password, yeah, you can get like log into that. Okay, it's something like that. So that's a very fundamental basic example, but there are real-time scenarios where it comes like this. You first do this. First time you do this, I never mind about my conditions anything. First do the logic for one time, and from if you wanted to do for if you want to do it for the next time, so then what you have to you have to check the it's going to check the condition. If the condition is satisfied, then only it will it will go back and execute it. It's what called do while. So as it says the do, yeah, do it. Just do it for the first time. And if you want to do the same thing again and again, then yeah, the condition should be satisfied. Okay, that's all about a simple do while. Okay, so here you can take the counter value, the same thing we can here you can write the same thing, counter value, say counter less than or equal to 10. Okay, then here I'm going to write system dot out dot println. So here I'm printing hello, and I can print the same logic. The same logic whatever we did in the earlier program. I am writing same logic with the do while. That's it. Okay, the syntax you have to understand. That's it. Now nothing great around this. Okay. So is it fine? Syntactically, any issues with this? Yeah, if you compile it, you will get to know. Okay, Java. Do while I have to do it. Okay, Java C do. That's what. Okay, I'm expecting this error. So this is what intentionally I did not keep it. Okay, so here if you look at it, is expecting what semicolon. So that is what you have to important. Many people confuse with this. So this is what the complete one single statement. Okay, in Java every statement should be terminated by semicolon. That's what. So do while. So this is what is single statement. This is what is single statement. This whole is considered as a single statement, but inside that it might be having a number of statements. Doesn't care about that. But this do while should be terminated. That is important. Okay, syntax. It is a syntax and that you have to follow. Now, so Java statements. Okay, so come on. So it's not stopping it, right? So let's keep going it. Counter is not incremented anywhere. Counter will be always one less than or equal to 2, true, and it goes back and execute. And counter is always one, right? That is not incrementing. So it will go for infinite times. So we need to increment the count. Okay, before getting into the next loop, you have to increase what? You have to increase what? Counter. That is important. Okay, if you miss, it will get into infinite loop. Now you can see the same one. Hello, 1, 2, 3. Okay, this is a simple do while example. Okay, do while example, and the same thing we can do the same thing using for loop. Okay, we can do the same thing using for loop. So here, say for example, I have a for. Okay, for loop, for condition, whatever it is. Okay, so here if you observe this while or do while, whatever it is, right? So total we have 3 steps. Step 1 is initialization, step 2 is condition, step 3 is the logic or increment or decrement operator. Okay, okay, so here we have steps. Okay, initialization, okay, then condition verification, and then increment or decrementing the value. These are the 3 factors, 3 important factors, considerable factors if you're writing the loops. Okay, if you're working with the loops, these are the 3 things that you have to keep in mind, right? You have to initialize the counter variable, then you need to write the proper condition, then you should do increment or decrement operation. Okay, So all these three we are doing it separately, right? So first we are doing this, then we are writing the condition, and somewhere else we are doing this increment of it. And these three are kind of template, fixed template. So if you are writing a loop, then it is compulsory, right? These three statements to be written. This is compulsory. Okay, this is compulsory. So that means that, so you can say this is a template, a pattern. Okay, now so why can't I combine all these three things into a single statement instead of writing all these three separate statements? Why can't I write all these three things in a single, okay, in a single line? That is where the for loop is introduced. So you write all the things inside this simple for loop. Okay, so what is that? Initialization. Okay, boss, this is one statement, then you write the condition, another statement, then you do increment or decrement. Okay, that's all. You write everything inside this for loop, write everything inside this loop. And here you just focus about your logic inside the body. This we call it as a body, and you write the logic inside this is what a simple syntax of for. And if you observe the same logic, how can I implement? So here the counter variable, right? Counter equal to 1, you just write for loop here into counter equal to 1, and then you take the condition counter less than or equal to 10. Then you have to do what? Increment or decrement. So counter equal to counter plus 1. So all three statements I am writing all together. That's all. Okay, now so you just remove this, just need to remove this. Okay, and need to remove this. Inside the body you have only the logic. Okay, inside the body you have only the logic and all other logic, so you move to together, and only within the body you focus on your logic. Okay, understand guys? Hopefully you understand. Okay, okay, so for loop syntax. Right, so this is simple parallel. Now let's just go back and execute the same thing. Now see, there is error. Okay, what is that? Something bracket is missed somewhere. One, two. Here I don't have a bracket, so keep the bracket. Okay. Just executing it, so it's printed for 10. That's it. So the same problem we have solved using different kind of looping statements. Okay, all works in the same way. Okay, so just some handy way of usage. So in our working environment, most of the people, most of the programmers prefer this for loop. Okay, for loop, because like we'll keep all things together. Okay, so the execution process, if you see, this executes only once because it's initialization, and condition has to be verified every time, and the counter value increment or decrement should happen every time. Okay, it should happen every time. And then body execution. Okay, this is what step number 1. Step number 2, then body execution. Step number 3, then again it goes back to increment or decrement. This is what step number 4. Then again it verifies the condition. Step number 5, if the condition is satisfied, it executes the body. Again it will increment or decrement, it will go here, say step number 7. Again it will check the condition. Step number 8, again if the condition is satisfied, it executes the body. Step number 9, like this it will go. Okay, this executes only once. That is what the whole point. This executes only once because it's initialization, and remaining stuff keep executing it. Okay, right. Yes, so hoping this makes clear about these looping statements. And the last one is we have for each loop. Okay, For each loop, it is something like when you have a list of things, when you have a group of things, when you have array of things, okay, when you have array of things, then you can use this particular for each loops. Okay, this is a specific enhanced for loop. This is specially designed for handling with collections. Okay, group of things. It is something like when you have a bag. Okay, when you have a bag of things, I don't care about how many items are there. In the previous example, whatever we have seen is about there is a restriction, right? 10 times or 100 times or 1000 times. Okay, there is a boundary, and so we are starting from the one and we are going through the iterations till we reach the 1000 or 100, whatever boundary. Okay, but here I don't care about that boundary. Okay, say for example you have a bag of items. Okay, so I have asked you to, okay, pull everything from the bag, pull out everything from the bag, so meaning that vacate everything. Okay, so get that empty, so remove everything. How many things are there? Remove everything. In that case I don't care about the number, how many total it has. My target is what, so I have to remove everything from the bag. I'll keep pulling it out one by one till it gets empty. Till it gets empty. Only I will check that. I don't care about what the counter and all. I don't care about the counter and all. So that is where the for each loop helps. Okay, the for each loop helps. So it's going to be, the syntax is going to be something like this for every item. Okay, for every item. Okay, for every item in the bag or a group. Okay, you do this, that's it. No initialization, no counter, no conditions, nothing. So here you write the logic, that's it, simple. This is enhanced for loop. Okay, no conditions, no checkings, nothing. So for every item in the bag you do the logic, simple, very simple. Okay, so for this, yeah, we should have some idea about some collections. Okay, um, so this is you cannot do the same logic here, because for each loop is it has some special purpose. Okay, so you need to have a group of things. Okay, let me show you a simple example by taking a simple collection, but don't worry about that, only focus on the for each loop, understand the for each loop. Anyhow, we'll discuss all this in further sessions. Okay, so for each loop example, right? So here if you look at, right, I'm going to define a bag. So bag, in the sense, yeah, you can take simple array also, of course. I'm taking some array list, which is a collection in Java. Okay, I'm taking a array list. Okay, al dot, I'm adding some numbers to this. Okay, I'm adding numbers, 10. I'm just adding numbers to the bag. Okay, so this bag might be having list of employees, list of products, list of items, anything. So now I'm having what, list of numbers. Okay, I'm having what, list of numbers. So I have some list of numbers like this. Now I don't care how many items are there in my list, my bag. Okay, but what I do is for every item in this list. Okay, so what kind of type it is, so here the type is going to matter. Okay, so it is integer, right, for every number inside this. Okay, inside the array list, so I want to print the number, that's it. So this is what my logic here. I wanted to print this system.out.println. Okay, so just I want to print the number, that's all. This is what my print logic. Okay, so this is okay. This array list is a predefined this array list is a predefined Java class which is already available. We just need to import that. Okay, so we'll talk about this in further sessions. Okay, so it is existed in java.util package. We have something called array list. Okay, we have something called array list. Okay, so we need to import that to make use of it in our program. Okay, now we can execute this and we'll elaborate. Let us compile this Java C for each loop. Okay, so I have an error. What is that? Cannot find the symbol. Okay, something I have used in a wrong way. It should be array list. Okay, spell mistake it is. Okay, spelling mistake. Okay, so now I have some errors here. Incompatible types. Object cannot be converted into int because so I have not specified any type here. So what I do is I'm just marking this as a generic so that it will accept only integers. Okay, so don't worry about all this logic. You focus on only on this to understand this. Again, I'll discuss this during the collections one more time. So don't worry about that. So here I have integer values. Okay, only integer values. So now you just compile it. Will compile and execute this. Okay, execute this. It's going to print the values 10, 20, 30, 40, 50. So that is what a simple logic of this. So here the syntax, if you look at for every time when you are doing this, right? So for you have to specify that type because Java is a okay strongly typed programming language. You have to define the data type here. Okay, so every item data type, and you just have the variable and the collection you are going to have. Okay, this is the syntax. This is the syntax. Is it clear? Or any confusion? So how to declare a collection, how to add the numbers, this is what, but we'll discuss in the collections in detail. Okay, you have to focus about this enhanced for each loop. It's a loop. So what will happen now? It brings up the elements from this collection. Okay, I have a list of elements here, total 5 elements. Okay, so it iterates through each and everything. It doesn't care about how many elements are there in the group. Okay, in the collection it doesn't care about that. Okay, it is going to pick the value one by one till it become empty. So it starts from here, it pulls out this, and the number is going to initialize. The number is a variable, right? So the 10 comes into the number for the first time and it will print, and it will go to the next number. 20 comes into the number, 30 comes into the number, 40 comes into the number, 50 comes into the number. It will print each time. It's going to print those numbers. Okay, and here type it is integer, right? So you have to specify the type. Here you can write the same integer or int. Okay, because it automatically converts integer object into primitive. There is a concept of auto boxing unboxing. We'll discuss about that later. Okay, this is about a simple for each loop. Okay guys, so do you have any questions about the iterative statements? Do you have any questions around the iterative statements? Come on, speak out. Good. Aditya, have you followed all these while loop, do while loop, for loop, and enhanced for loop? Okay, these are the categories that we have to iterate through the elements. Aditya, followed? Okay, Shankar. Okay, fine. So for tomorrow, can you write a program? Write a program now. Write a program to find the given number is a positive number. I think sometime back I have given this. Now you have to use the conditional statements. You have to use the iterative statements. All this combined. Positive number. A number is positive, and then find it is a prime number or not. Prime number or not. Okay. You write the program tomorrow, and also I wanted to you guys give a try to print this series 1, 1, 2, 1, 2, 3. This is a pyramidc series. Okay, just this gives some practice. Okay, to think about the logic. Okay, to think about the logic, you have to use some nesting. Okay, or however what you wanted to do. you do it, but write a program to print this series, okay, below series. Okay, do these two programs by tomorrow. Okay, right. So we'll see. We'll continue tomorrow, right?